Good afternoon all. Welcome to BT Studio. In this session, we entered to the last unit. That means unit number 6 of the microcontroller and applications subject. And the unit name is Interfacing the 8051. This is the contents of the this last unit. And basically it's a 7 hours of teaching, and you can expect 20 marks from this chapter. 5 marks 2 question in the part A and 10 marks 1 question in the part B. So totally 20 marks. Totally it's 14% of the total marks weightage. And this is the contents: multiplexer 7-segment display, LCD module, analog to digital converter, 0802, waveform generation using DAC, that means digital to analog converter. Opposite of the ADC is the DAC, digital to analog converter. 0808 is the just like IC number. DC motor, pulse width modulation. With the help of the pulse width modulation, how to control the speed of the DC motor. Similarly, stepper motor. The main difference between the DC motor and the stepper motor is DC motor, there is no any step angle. It not rotate in terms of steps. But stepper motor, it rotates in terms of steps. Each and every step having its own angle. That angle is called as the step angle. So here stepper motor and appropriate schematic. Schematic is nothing but the circuits and algorithm and C programs. I think you might have already discussed the programs and algorithm in case of the same lab, microcontroller and applications lab. So first we move to the multiplexer 7-segment display interface. Interface is nothing but, in the previous class we discussed about the serial communication. For that one we are using the SCON resistor, that is the serial control resistor, and SBUF resistor, TCOM resistor, TMOD resistors. These all resistors are used by this 8051 microcontroller when it is doing the interfacing. Interfacing means communication with the external devices. In the previous slides I've shown you, for example, it may be a 7-segment display, it's an external device, it may be DC motor external device, or it's a stepper motor external device, how it will communicate. So here, what is the circuit diagram? That means what is the schematic, and which is the particular procedure to interface the 8051 with those external devices. In the first one is multiplexer 7-segment display. You might have know about 7-segment display. Why it is called a 7-segment display? Generally, you can see the 7-segment display in case of digital watches. Digital watches, and it may be a traffic light controller, lights, where you can see the 7 segments. It consists of the 7 segments. See this diagram. So 7 segments. When you look like it, look like an 8. For each and every segment, you are giving a name. Like it starts from the top to bottom in the right direction. It's a A, it's a B, it's a C, D, E, F, G. Totally 7 segments are there. It will display some value. It will display, it may be a number. It will display a value. That's why it's called as the 7-segment display. Totally 7 segments are there. It will display some value. So here, first we will move to the little bit theory about the 7-segment display. Then we will move to the schematic. Seven-segment display consists of 7 segments: A, B, C, D, E, F, G. Here, how they are arranged each other. Start from the top and in the right direction, and finally end up in the left direction. 7 LEDs are used. Since 7 segments are there, each and every segment is nothing but it's an LED. So this is the symbol of the LED where it emits the light. That's why it's called as the light emitting diode. It emits the light. So that for each and every segment there is a LED. So totally there are 7 LEDs are used in 7-segment display. In each 7-segment display, 7 LEDs are there. Each LED corresponds to each segment. By forward, how these LEDs are work in the 7-segment display? By forwarding them. When you come to that name of the diode, it may be a junction diode, Zener diode, or it may be a light emitting diode. So there are 2 biases are there. Biases is nothing but applying the voltage, suitable voltage. Okay. So here, whatever the LED we are using in the 7-segment, it will work or it will display the value. It will on, it will turn on when it becomes forward bias. What do you mean by forward bias? When positive terminal of the battery is given to the anode, This is called as the anode, and the negative terminal of the battery should be given to the cathode. This one. Then it is called as the forward biased. Here, if the LEDs, all the 7 LEDs become forward biased, then only they will emit the light. Emit the light means, okay, that portion will on, that portion will glow, so it indicates some gadget. By forward biasing LEDs, we can display the 0 to 9. So in 7-segment display, we have started from the 0, we can maximum display the digit of 9 only. After 9, okay, to display the further digits, it may be A is not possible, particularly 10, 11, we should require the 2 7-segment displays. They are placed beside each other, so that we can display a digit from 0 to 9. Okay. Then 7-segment display may be of, there are 2 types of 7-segment display we can use in 2 various methods. One is called as the common anode type, common cathode type. Sometimes it's called as common anode method, common cathode method. Okay. What exactly common anode? As the name itself indicates, in common anode type, okay, this is called as the anode. All the anodes are connected to a common point. From that common point, we are connected to plus VCC. Here, all the anodes. For example, here one LED is there, similar to the, okay, if for one 7-segment display, we require 7 LEDs. All the LEDs anodes are connected to one common point, connected together to a one common point. From that point, we are connected to a VCC. Here, VCC indicates it's a plus 5 volts DC. That means the DC voltage of 5 volts. Cathodes are connected to A to G inputs. Okay, all the anodes are connected to supply, that is the plus 5 volts DC. All these cathodes are, how much cathodes are there? 7 cathodes are, because 7 anodes, 7 LEDs, 7 anodes, 7 cathodes. All 7 cathodes are connected to where they are connected to A to G. First cathode should goes to A, and last cathode should goes to G inputs. And when the 7-segment display will glow, or when it turn on means all the cathodes should be connected to, this means active low. Active low means ground. Cathodes connected to A to G, and also the cathode should be connected to ground. Why it is called a ground is called as active low? Because the ground voltage is always 0 voltage. Okay, that's why this cathode should be connected to ATG. In addition with that, when they are connected to what? Ground. That's why here the A to G input should be active low. Active low is nothing but what? It's a 0 voltage or ground voltage to activate the LEDs. Okay, the anode should be connected to positive power supply of 5 volts. Cathode should be connected to what? Inputs, and finally they should be connected to a active low. Active low means ground connection. Then only the particular LEDs will glow. That's why it's called as the forward bias. Anode should be connected to positive of the power supply. Cathode should be connected to what? Negative. Negative is always connected to a ground. Okay, that's why they finally they will activate. Activate means they will glow. Okay. Now here there is one problem is there. LEDs require more power. LEDs require more power compared to LCD. That is the second topic in this chapter. LCD, liquid crystal display. LEDs normally they require more power. Okay, that's why here to reduce the power usage, when there are 7 LEDs for each display. Similarly, if there are the 2 displays, then 14 LEDs are there. Like that. So if the number of LEDs are increases, then the consumption of the power is also increases. To overcome the disadvantages, there is one method is there that is called as multiplexing technique. That's why in the headline, multiplexed 7-segment display. Normally we are called a 7-segment display. Okay, if there is only one display is there, if more than one display are there, more than one 7-segment display is there, then it's called as the multiplexed 7-segment display, because we are adopting a multiplexing technique. What exactly multiplexing technique? I will tell you. So multiplexing technique is used to reduce the power requirements. If you adopt this method, then normally how much power supply it is used, that power supply is what gradually reduces. Okay, so that's why it's called as the multiplexing technique. Here in this diagram, this is a circuit diagram actually. So just see this schematic or circuit diagram. Here there is a 8051 microcontroller is there. The 8051 microcontroller. There are 4 ports are there. Among 4 ports, I am using here port 0 and port 2. Okay, by default, I am using port 0 and port 2. Fine. In addition with that, so there is a driver circuit to drive all the 7 segments. there is a driver circuit named as ULN2803. It's a IC number. It's generally called as the 7-segment display driver circuit, supporting circuit. Without this driver circuit, we cannot operate the 7-segment display. Directly, we are not able to connect this displays with the 8051 microcontroller. Directly, it is not possible to interface. That's why there is a mediator circuit. Okay, in between these two, that is called as the driver circuit. It will drive these displays. Okay, so here, how much displays are there? 4 displays are there. This is the first 7-segment display, second, third, similarly fourth. If more than one is present, generally we are called as multiplex. Multiplex means many, more than one or more than 2. So here, 4 7-segment displays are there. That's why it's called as the multiplexing or multiplexed 4-digit. It's actually 4 digit is nothing but here 1, 2, 3, 4. Okay, we can at a time we can display 4 digits. For example, here 1, 2, 3, 4, like this. Okay, since more than one display is there, it is called as the multiplexed 4-digit 7-segment display interface with 8051. So here actually multiplexing is technically multiplexing is okay. So the power supply, or generally what we are called as the current to all these displays is not given simultaneously or not given continuously. It is given, it is applied, the current or power supply is applied, it's in terms of pulse. Okay, multiplexing is nothing but for all these 4 displays, the power supply or the current is not applied simultaneously, not applied continuously. Okay, so it is pulsed. Pulsed is nothing but, so whenever you want this digit, only to this digit the current is flowing. Whenever you want 2 digits, then for this display and this display current is flowing. For these two, the current is not flowing. Okay, that is called as pulsed. Which displays we want to use, or which 7-segment displays we want to use, only to those 7-segment displays the current will flow and not to all the 4 displays. That is generally called as multiplexing technique. And also there are more number of displays, that means more than 1. Okay, so here just see here, in addition to the 7 segments, there is another small segment is there. This is called as the DP. DP means nothing but decimal point. Decimal point. For example, if there is no decimal point, sometimes if you want to display the floating point means 8.5, 10.5. There is a other than the integer. Integer means it's a single digit is there. Okay, if there is a floating point, okay, at that time this DP, there is the decimal point will help. So that's why there are 8 lines are there totally. These 7 lines are starting from here. See here, they are mentioned here. This line is reserved for A, that is the first segment, and this line is reserved for last segment is the G, A to G, and this segment is reserved for the DP. DP means decimal point. If you want to display any floating point value, then this what's called this DP will help. So that see here, I am using a port 0. This port 0, each port is mentioned by a digit 1, digit 2, digit 3, digit 4. These digit inputs, they are connected to each and every transistors. Here the transistor I am using is the PNP transistor. See, in the port number 0, I am using the 4 connections. Okay, that is the 0.0, 0.1, 0.2, 0.3. Each are called by the name digit 1, digit 2, digit 3, digit 4. Means they will control the on and off of this displays. These 4 digits, 0.0, 0.1, 0.2, 0.3, they are connected to each and every transistor. For example, see here, port 0.0 is called as the digit 1. It is connected to a what? Transistor 1. That is the T1 via a current limiting resistor. This is called as the current limiting resistor. Okay, similarly, the digit 2 here, the digit 2 it is connected to a transistor 2, that is the T2 via current limiting resistor. Similarly, port 0.2, that is called as the digit 3, it is connected to this is a transistor 3 via same current limiting resistor. Finally, 0.3, that is called as the digit 4, it is connected to where? It is connected to last transistor, that is the T4 via same. See, okay. Here, the current limiting resistors are used. How much of current is required to display that value? So it will limit to that current. Okay, this current limiting resistor. See here, the activity of these four transistors is controlled with the help of this digit 1, digit 2, digit 3, digit 4. That's why they are directly connected to the PNP transistors. Similarly, we are using another port, that is the port 2, starting from all the pins we are using. Okay, starting from 2.0, ending with 2.7. There are totally 8 pins are there. So out of 8 pins, 7 pins are used to control the 7 segments. And the last pin is used to control the what? This decimal point. That's why when you look at here, okay, via a current limiting resistor again, see here, starting from A, there are up to G, there are 7 lines are there. Each and every lines are connected to this port 2.0 via this driver circuit, and finally this last port P2.7, it is connected to decimal point. It will display. There is a decimal point. It will display. Otherwise, it will not display. Okay. Similarly, all the displays are connected to a same port. That is the port 2.0. Okay. Fine. Now here, how it will work? Generally, how it will work? See here. In addition with that, this current limiting resistor, there is a external pull-up resistors also there. Okay, external pull-up resistors. They are also used to limit the current. In addition with this. Okay, that's why see here, they are connected to what? VCC. They will limit the power supply. So that when the digit here, digit 1, digit 2, digit 3, digit 4, when the digit is 0, see here, when the digit is 0, any digit, it may be digit 1, digit 2, digit 3. If they are 0, okay, if you have not applied any input here, that is nothing but 0, then the transistor will on. The transistor will turn on. Here there is a reverse. Okay, when this input is 0, that means the digit 1, digit 2, digit 3, digit 4 inputs are 0, active low, then the transistor will turn on. When they will turn on, they will also turn on this displays. Okay, because the transistor is act as a switch here. When the transistor on, that is nothing but switch on. Okay, it will turn on these displays. Okay, finally it will give this some value. When digits are 1, instead of 0, when all these digits are 1, okay, so that there will be reverse operation. When all these digits are 1, the transistor will turn off. Turn off means switch is off. Okay, so that there is no any display on this 7-segment display. There is no any value. There is no any information on this 7-segment value. Okay, so there is a direct method is there. When the digits are 0, the transistor will off. On. The transistor will on because reverse operation. When the digits are 0, so the transistor will on. Okay, so when they are on, the switch is on because transistor acts as a switch. When they are on, these displays are also on. Okay. Similarly, when these digits are 1, 1, that means when the digits are on, there is a reverse operation. The transistor become off. Okay, because the digits are on here, the transistor become off. Nothing but the switch is off. Okay, when the switch is off, these displays are also off. In this way, okay, the 8051 is interfacing with the 7-segment displays. Okay. So if you are using only one display, then it is not called as the multiplexer 7-segment display. It is simply called as the 7-segment display. This table indicates how we can get the output. Okay, in the display. See here, decimal number, what we can understand. But the 7-segment display, it did not understand this decimal number, so that we can should convert into the binary numbers. Finally, we should convert into a hexadecimal number. These hexadecimal numbers are called as the codes. These code we should incorporate. These code should be used while writing the program, assembly language program, to display the 7-segment. With the help of the 8051, these codes are important. Okay, so here, see here, the port P2.7. Port P2.7 is nothing but here. Port 2.7. It's connected to what? A. I told you in the previous slides, it's connected to A. Similarly, port 2.0, see here, it is connected to what? Decimal point. Fine. Okay. So that here, port 2.7, it is connected to which segment? A. Then port 2.6 is connected to B, second segment. Port 2.5 connected to C. then 2.4 D, E, F, G, DP means decimal point. In addition with 7 segments, there is another segment decimal point, totally 8. Divide this 8 equally. Okay, you can get the 2 nibbles. Okay, now A, B, C, D. It is the 1 nibble. E, F, G, G, D, P. This is the another nibble. Okay, divide into 1 byte is now divided into 2 nibbles. Okay, A, B, C, D is the 1 nibble or half of the byte, and E, F, G, D, P is the another nibble. Okay, to know how we can get this codes. Now, the decimal number. Now there is a imagination is required. Otherwise, okay, you should consider the standard display format. The standard display format here. The standard display format. See, if you want 1, then only see here. Okay, only B and C are enough to display 1. B and C are enough. So that see here, B and C should be 1. Remaining should be 0. Okay, so that here some imagination is required. So you consider the standard format or standard display of the 7 segment. So that to get the 1, only B and C are enough. Only B and C are enough. So where B and C, put 1 means the LEDs B and C LEDs are only on, remaining are what, off. Okay, so that how we can convert into a hexadecimal. See here, 0, 1, 1, 0. In case of B and C, only 1 is there. Remaining are the zeros. Consider the powers of binary. That is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. LSB should be right side, least significant bit. MSB should be left side, most significant bit. Wherever 1 is there, consider that weight or consider that power. For example, if the 2 to the power of 1, 1 is there. 2 to the power of 1 is equal to how much? 2. In the 2 to the power of 2, 1 is there. 2 to the power of 2 is equal to how much? It's a 4. Okay. 4 plus 2, how much? 6. Here you can get the 6. Okay. Similarly, in this nibble, no, in any of the places, there is no 1. Okay. So that don't consider in any powers. Simply, finally consider 0. So that totally you can get 60 hexadecimal number. Same thing you should use in case of writing AL. Okay. Similarly, 2. See here, 2, how you can get? A, B, like this. A, B. This is the 2. Okay, A, here it's a B, then C, there is no use of C, it's a D, then E, there is no use of F, G. Okay, some imagination is required. A, B, D, E, G. So that here, A, B, D, E, G. Remaining are the 0. 0 means, so those segments are not activated, not glow. Only these are activated. A, B, D, E, G. So it looks like a 2, number 2. Okay, remaining are the 0. Then again divided into a nibble of 4 bits. So 1101 is the 1 nibble, 1010 is the another nibble. Here, okay, allot the weight again. In the place of 2 to the power of 0, 1 is there. 2 to the power of 0 is equal to how much? 1. In the 2 to the power of 2 place, 1 is there. 2 to the power of 2 is equal to 4. In the 2 to the power of 3 place, okay, 1 is there. 2 to the power of 3 is equal to 8. 8 plus 4, 12. 12 plus 1, 13. But in hexadecimal, 13 is nothing but how much? Okay, because A is 10, B is 11, C is 12, then D is 13. Here it's a D. D is 13. In hexadecimal, okay, 13 is nothing but what? D. Similarly, in the another side, 1010. Allot the same powers, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, because it is not easy to remember these codes. Okay, we should follow this technical method, then only you can easily remember which of the codes should be incorporated in the programs. Okay, so that here in the place of 2 to the power of 1, 2 to the power of 1, 1 is there, 2 to the power of 1 is equal to how much? 2. In the place of 2 to the power of 3, 1 is there, 2 to the power of 3 is equal to how much? 8. 8 plus 2, 10. But in terms of hexadecimal, 10 is nothing but what? A. A is 10, B is 11, C is 12, like this. F is nothing but what? Finally 15. That's why DA is the nothing but what? It's the hexadecimal code we should use in the program. Like that, there is an important point here. When all the displays will be active, when all the segments will be active, when all the segments will be active means when the decimal number is 8, then all the segments A, B, C, D, E, F, G are active. Okay, and when minimum segments will active, when minimum segment will active means for 1. See, for 1 decimal number 1, minimum number of segments will active. See here, only 2 segments. For 8 decimal number, maximum number of segments. Maximum means all the segments are active for 8. This is one of the question. Okay, they are asked majority times in the Viva related to lab. So for 8, all the segments are displayed. For 1, minimum segments are displayed. Like this. Okay, you can divide into a nibble, then finally convert into a hexadecimal code. And finally come to here, DP. DP means decimal point. Which pin number is connected to decimal point? Which pin number is connected to decimal point? Here, port 2.0. Port 2.0 is connected to what? Decimal point. Decimal point. Okay. That's why in the truth table, see, port 2.0 is the one, remaining are the zeros. Okay. So that finally it becomes 0 and 1 H if you convert it into a hexadecimal. This is the truth table where you can understand. So in which format, okay, in which are the segments will display and which are the segments will not display. Okay. So I told you earlier, if you want to see this 7th segment, then better to observe the traffic light where all the numbers are displayed in 7th segment format only. That is minute minder or seconds minder. They will all use 7 segments. Okay. This is very easy. There is no any shortcut method. There is no any shortcut method to write this one. You should imagine the 7 segment. Okay. And sometimes, and one more confusion, many of the people, they will ask, for example, 6, how it will display? Okay, the 6 display like this. In some of the 7 segments, there is no A. Okay, the 6 will display like B. Okay, better to write this A also, segment A also. A, B, C, D, E, F, G. C for 6, A, B is 0, B is 0, C, D, E, F, G. So that in normally the 6 will display like this. Okay, not like it B. Okay, so that you should not write like B. Similarly, 9 opposite of the 6 or ulta of the 6, it is also displayed like this. Okay, some of the people they will consider only this A, B, C, D. They will not consider E. They will not consider A, B, C, D, E, F, G. Okay, it looks like a not 9, exactly 9. So that consider this C also. So finally, it becomes the reverse or ulta of the 6. So now we are move on to the LCD interface. Before going to the LCD interface, then what is the difference between LED and LCD? Okay. So I told you best example for the LED is the traffic signals or your digital watch. Then this LCDs where you can commonly see is nothing but liquid crystal displays where there is a in microcontroller this LCD will arrange in the form of the rows and columns. It will arrange in the form of the rows and columns. Okay, means for example, when you press the display, you can sense a fluid. A fluid is moving. For example, in LCD TVs, okay, LCD monitors. So there is no any standard format. For example, in 7-segment display, so there is a standard format. There is no any bending of the segments. The segments are always straight like this. The segments are always straight. And in 7-segment display, it is very difficult to display the characters. Characters like A, B, C, D. It is very difficult. Numbers display is very easy in 7-segment display. But if you display A, B, C, it is highly difficult. And even though you try, it's not looking good. Okay, to overcome this disadvantages, we are using the LCD, liquid crystal display. For example, in city bus display is there. No, it's not exactly liquid crystal display. Okay, but it's same. There is a bending. There is a bending. For example, you can display A, B, C, all those things. There is no need of straight lines. Okay, so here earlier I told that this 7-segment we are using LED, light emitting diode. Okay, the cost of the light emitting diode is more because it consumes the more power. But LCD, the cost of the consumption, the cost of the LCD is less because it consumes low power. Okay, that is the main advantage. Consider 7 segment, that is the LED and is LCD. LED consumes more power, so the cost is more. But LCD consumes less power, the cost is what? Less. And here, the LED, one advantage is means for LED, there is no requirement of the external power supply or external light source is not required for the LED. Internal light source is enough. Internal light source is enough. Internal current or voltage is enough for the LED. What we are using in the 7 segment display. But for LCD, internal, in addition with the internal electrical source or internal current source, we should also use the external current source. Okay, LED, internal current source is enough. External current source is not required. But for LCD, in addition with the internal current source, external current source is also required. Okay, there is the one disadvantage. And finally, this LED is called as the light emitter. LED is called as the light emitter. Okay, but LCD is called as the light controller. LCD is called as the light controller. Okay. Advantages are also there, disadvantages also there. Totally, when you're taking the cost, the LCD cost is very less because it consumes the low power. Okay. Then we are moving to the how to interface the LCD with the 8051 microcontroller. Okay, before going to that one, we are moving to the some theory. Liquid crystal display, full form of the LCD is the liquid crystal display, are used. Similar applications where LEDs are used. Okay, where LEDs are used means to display some value. No, for same application we are using the LCD also. But here the main advantages of the LCD is it will display not only the numbers like 7 segment, it also displays the alphanumeric characters. Alphanumeric character means A, B, C, D, all the characters. Okay, in addition with that numbers. Okay, in dot matrix display. There in the 7 segment, they look like a line, straight line. But here the display is like a dots, where all the dots are arranged in the form of the rows and columns. That's why it's called as the matrix. Where you come to the word matrix, when there is a rows and columns, then only it's called as the matrix. Here, dots are arranged in the form of the matrix. That's why it's called as the dot matrix display. The LCDs are passive displays. I already told you. Passive. Opposite is what? Active. Okay. The LCDs are the passive displays because they will not generate the light. They will not generate the light their own. They modify the existing light. What I told you earlier, they require the external light also in addition with that the internal light. Okay, or internal current. They also want external current. That's why they are the passive. Passive means they are not any self-generation of the current. Okay, they are light. They require the what? External light so that they will modify the external light or existing light. Okay. Hence, LCDs are light controllers. I told you, no, LCDs are the light controllers, but LEDs are the light emitters. That's why it's called as the light emitter diode. Okay, and they require an external source of light. In addition with the internal source of light, they also require external source of light. Okay. So here, LCD displays are dot matrix displays where the dots are arranged in the form of the rows and columns. Okay, like this. Rows and columns. Like this, the dots are arranged. Okay. Majority of the time, when you are displaying alphanumeric characters, we are going through the what? This dot matrix displays are LCDs. Okay, when you display both numeric and the numbers as well as characters. Okay. The common matrix sizes are 5, 7 or 7, 9. Okay. Here the first number indicates the row and the second number indicates the column. Generally, there are two types of dot matrix displays. Means LCD displays are used. Okay. They are available in the market. One is called as the 5 into 7, another one is the 7 into 9. 5 into 7 is nothing but there are 5 rows. There are 5 rows. Okay, and there are 7 columns. Just imagine 5 rows of dots, 7 columns of dots. For example, here, see 1, 2, 3, 4, 5. 5 rows are there. 1, 2, 3, 4, 5, 6, 7. This is the best example for the 5 into 7 dot matrix display or 5 into 7 LCD display. where 5 rows are there and 7 columns are there. Like this, it is arranged. So if you want the more lengthiest display, then you can go to the 7 into 9, where 7 rows and 9 columns are there. Okay. By switching on some of the dots and switching off some of the dots, any alphanumeric character can be formed. Okay, here by switching on some of the dots and by switching on which dots you want, then you can switch on those dots. Which dots you don't want, switch off those dots. So by using that switching on and switching off of the dots, you can display any alphanumeric character starting from 0 to 9, A to Z. Okay, you can display these alphanumeric characters. Okay, in Citybus there is a display is there, no? Like that similar way there is a this LCD display is also. Okay, here there is a liquid fluid is used. Inside the LCD there is a read-only memory which stores the required dot matrix code for the corresponding ASCII input. ASCII input means whatever the input you are enter through the keyboard. The keyboard is called as the ASCII. Inside in the keyboard there is a ASCII converter, American Standard Code for Information Interchange. So whatever the letters or numbers, totally alphanumeric characters we are entered through the keyboard. Okay, they are converted into a ASCII code. They are converted into a ASCII code because computer cannot understand our decimal numbers or our characters. Okay, so that it will convert into a ASCII code. That ASCII code is stored in the read-only memory. Where exactly the read-only memory? LCD. Each and every LCD display having the read-only memory. In that read-only memory, whatever the inputs we are given, that inputs are converted into a first ASCII. Okay, that ASCII is stored in the read-only memory. Then finally, according to that ASCII input, it will display the value through the LCD. Okay, so that inside the LCD there is a ROM which stores the required dot matrix code for the corresponding ASCII input. Okay, so the ASCII input is stored, and also according to this ASCII input, the corresponding dot matrix code, that means LCD, is displayed on the particular rows and columns of display. Now we are moving to the how this LCD display is interfaced with the 8051 microcontroller. Here is the 8051 microcontroller, and this is the LCD display. In LCD display, there are many pins are there. So among those pins, we are using only this much of pins for displaying the particular value or particular character. Okay. So here in 8051 microcontroller, we are using two number of ports. One is the port 1. In port 1, we are using all the 8 pins from starting from 0 to 7, 1.0 to 1.7. So there are 8 pins, 1, 2, 3, 4, 5, 6, 7, 8. Okay, to carry the data or command. So this D0 is there, not here. D is nothing but what? Data or command. Okay. So similarly, we are using the port 2. In this port 2, we are preparing 3 pins. One is the 0, 1, 2, 3. These pins are connected to RS, R bar W, and E. I will tell you what exactly RS will do, R bar W will do, and enable will do. And these are they are related to power supply parameters. VCC, VEE, VSS. Okay, there is a part to control the power supply. There is a part 10 kilo ohm part. Okay, this is the schematic or circuit diagram to interface the LCD. This interface the LCD. Okay, it may be a 5 into 7 LCD or it may be 7 into 9 LCD. Okay, so they are using this 8051 microcontroller. Now we are moving on to this. In the previous diagram, there are 3 parameters. I told you there is a power supply parameters. Okay, VCC, VEE, VSS. VCC, VEE, VSS. This VCC, VSS, VE, they are related to. VSS is related to ground. Okay, source to source voltage. Generally, source is nothing but ground. VCC, 5 volts power supply, because the LCD required 5 volts power supply to activate. Okay, then VE is nothing but contrast controlled pins. Contrast. Okay, how with the help of the part here. If you tune this potentiometer part, we can adjust the contrast. This brightness or medium brightness or low brightness. So that's why this part is connected to what? This VCC, VEE, and so here there are three terminals, 1, 2, and 3. This third terminal is connected to VEE, where you can contrast which value you want or which much of what is called brightness you want with the help of this part. Okay, so that's why VSS is reserved for ground, and VCC is nothing but is a positive power supply of 5 volts, and VE is nothing but the contrast control pins. Similarly, there are three control pins are there. One is called as the RS, another one is called as the R bar W, and E. Okay, what exactly RS means? RS is nothing but you should read Ulta, select resistor. Select resistor. Okay. When RS is equal to 0, then it selects the commands. That's why it's called as select command resistor. When RS is equal to 0, it selects the commands. Okay. There is two types of parameters. One is the data, another one is the command. According to command, the data will what? Manipulate. Okay. So that when RS is equal to 0, it will only select the commands. When RS is equal to 1, it selects the data. That's why it's called as select data resistor. Okay. One is the select command resistor, another one is the select data resistor. Similarly, R bar W. Okay. R is nothing but here read, and W is nothing but what? Write. Okay. When why it is a bar means when it is 0, W is equal to 0, it will active. This is called as the negative strobe generally. Negative strobe. Negative means bar. When it is 0, then only it active. When W is equal to 1, it will not active like that. Okay. So that what happens when R bar W is equal to 0 and R bar W is equal to 1? When R bar W is equal to read and write is equal to 0, see here, write to LCD. It write the LCD from the microcontroller to this display. It takes the data from the microcontroller to the microcontroller we are applying through a computer. Okay. So that whatever you apply from the keyboard is converted to ASCII, stored in the RAM, and go to the microcontroller. From the microcontroller, it goes to the what? RAM of the LCD, ROM, read-only memory of the LCD. So that it write means it will display. It will display. Okay. R bar W is nothing but when R bar W is equal to 1, read from LCD. After writing, okay, it will display the final value. When it is writing, we can't able to read any data in the display. Okay. When after writing each and everything from the microcontroller, it is writing to the LCD. After writing, finally it will display that value. Okay, or display that character, display that word, so that when R bar W is equal to 1, we can read that value from the LCD. Okay, first one is the write to LCD from the microcontroller to the LCD. Another, we can read from the LCD the data. And next control pin is called E, enable. Okay. Latch data inputs D0 to D7 into LCD. Here, these are the D0 to D7 inputs. There are totally how much inputs are there? 8 inputs are there because there are 8 pins are there. Okay. So this enable, it latch all these 8 inputs. Okay, into the what this display. Fine. Enable latch data D0 to D7 into LCD. Latch is nothing but synchronize. Okay, the data inputs are synchronized with the LCD display. So that is called as the latching. That will be performed by enable. This enable should be always 1. Then only it will latch the data inputs, that is D0 to D7 into the LCD. When enable becomes 0, it will become the disable. It will not synchronize the data inputs into the display, so that we can't able to read anything from the display. Totally it is off. Okay, that's why E should be always 1. E should be always 1. It should be 1. Okay. Now the data bits. Whatever the data we are entered, the data is carried with the help of this data bits. D0 to D7. These are called as the bidirectional data pins. Okay, actually in this diagram there is only line only. These pins are called as the bidirectional data pins. Okay, they will carry the data and they will what's called recover the data from the display. From microcontroller to the display, they will carry the data, and from display to microcontroller, they will take the any signals, okay, or commands. So that D0 to D7 are called as the bidirectional data lines. You have the 8 data pins are there, 8 data pins used to send data or commands, byte. So 8 is nothing but what? It's a byte. Group of 8 bits is called as the byte. So that with the help of these 8 pins, 8 data pins, okay, we can send the both the data as well as the commands. Okay, to LCD or read from LCD. I told you already, they will carry the data or command. For to send the data, what exactly? RS should be what's called RS should be 1. Then they will send the data. When RS should be 0, they will what's called send the command. Like that we should change. So finally the same pins are used to send the data as well as what's called to send the command, okay, to the LCD, or we can read from LCD. These are which are the pins we are preferring in the LCD interface. Okay. So here, for both 7-segment display and LCD interface, both ALP is there as well as C programming is there. Okay, and already ALP and C programming you might have studied in the interfacing part of the microcontroller and application lab. Same programs, but the thing is you should remember these values. You remember these values. Then this value should be first you should accumulate to the accumulator. Accumulate means you should store in the accumulator. Then this will all the decimal numbers 1 to 9 they will going on display. Okay. In LCD, only numbers you can display any values also. These characters also. Okay. For this one also there is a C programming is there. And ALP is there, assembly language programming. The thing is how it will act generally. Then only we can move to the program. How you load the values and how you jump the loop from one point to the another point, like that. And whether we are using the long jump, there is a time delay is more, or whether we are using the short jump, or the time delay is less. So that we will discuss those programs, and still there are 3 further interfacings are there. One is the ADC, analog to digital converter, and DAC, and finally motors. In that motors, again, you should how to interface both stepper motor and DC motor to the 8051 microcontroller. All these are there in the lab, but theoretically, again, I will explain how they will interface. So that today we discussed the 2 interfacing. One is the 7-segment display interfacing with the 8051. Another one is the LCD interfacing with the 8051. Okay. The main difference is we can alphanumeric character we can display in LCD, but in 7-segment alphanumeric characters not able to display only numerical values. Okay. So if any doubts you can ask me.